today we're going to talk about trigonometric functions and functions. And finally, we're going to give you a debate about them. Trigonometric functions. Camila Agudelo is going to explain us what they are, and me and Daniela are going to explain you some examples for you to get it.
Carem, Acosta and Olga, Varon, who are going to explain what is a function, and then Juan Angulo, who is going to tell us some examples for us to get into the topic and understand better.
Trigonometry is the study of the properties of the triangle. The triangle of most interest in trigonometry is the right angle triangle. Each side of the triangle has its own name. This is the opposite side, this is the adjacent side, and this is the hypotenuse. And this is the angle theta. Let's talk about the special functions of the triangle. The special functions of the triangle are sine, cosine, and tangent. These functions help us to find a side or an angle that is missing on the triangle. First, we have sine, that is the first function in which we have to find the sine of the angle theta, and then we have to divide the opposite side by the hypotenuse. Then we have the cosine, that is the second function in which we have to find the cosine of the angle theta, and then we have to divide the adjacent side by the hypotenuse. And then we have the tangent, that is the third function in which we have to find the tangent of the angle theta, and then divide the opposite side by the adjacent side. The sides could be positive or negative depending on the Cartesian plane rules, and this means that the sine, cosine, and tangent could vary between positive and negative numbers. A technique to learn the different functions is Coca-Cola HH, in which this is the opposite side divided by the hypotenuse, that is sine. Then you have the adjacent side divided by the hypotenuse, that is cosine. Then the opposite side by the adjacent side, that is the tangent. Then the adjacent side divided by the opposite side, that is the cotangent. Then you have the hypotenuse divided by the adjacent side, that is the secant. And then the hypotenuse divided by the opposite side, that is the cosecant. Now let's talk about the Thales theorem, in which he says that the sum of all the internal angles are equal to 180 degrees, and all the external angles are equal to 360 degrees.
Wave after wind, slowly drifting.
We're going to complete this right triangle. Now we're going to find the side A, B, because we know the side C measures 6. We're going to find the angle A and C because we know that the angle B measures 35. We know that this angle here is the right angle, so we know that it measures 90 degrees. From the side B, we're going to use the Pythagorean theorem that says is A to the second power plus B to the second power is equal to C to the second power. We know that A is 11, so 11 to the second power plus B to the second power is equal to 15, that is C to the second power. 11 to the second power is 121 plus B to the second power is equal to 225. B to the second power is equal to 225 minus 121 because we want to isolate B. B to the second power is equal to 104. We take out the root square in each side, and B is equal to the root square of 104. Now we're going to find the measure of the angle A. And we know that the angle B measures 35 and the angle C 90. So we're going to add up those angles, and the answer is 125. Now we're going to subtract 125 from 180. That gives us the result of the angle A, that is 55 degrees. Now we're going to find the measure of the angle B. We're going to add up 37 degrees and 90 degrees. The measures of the angle C and angle A. This gives us a result of 127. Now we're going to subtract 127 from 180 because all the angles of a triangle gives us a result of 180. This gives 53 degrees. So now we can say that the angle B measures 53 degrees. Now for finding the side B, we're gonna take out the cosine of 55 degrees, and the formula is adjacent side over hypotenuse. The cosine of 55 degrees is x over the hypotenuse, that is 6. Now we take 6 to multiply to the other side with the cosine of 55 degrees. That gives us the result of x, or the result of the side B. Now we know that the multiplying 6 by the cosine of 55 degrees, we're going to take out B, so B is equal to 3.4.
A function f corresponds between two sets, set x and set y, in which you can assign an element to x, so you can solve the equation and find y. We can also say that a function relates an input to a single output, being the input the domain or set x, and the output a range or set y, are often written like this: f of x equals to something. X is just a placeholder. Where x stands, you can put any other element. You can put a, b, alpha, beta, whatever you want. Also, x is where the input value stands. There are different kinds of functions: logarithmic functions, exponential functions, inverse functions, and piecewise functions.
So, for identifying a function, we would have this. This is the function name. Function name. This one, the x one, it will be our input. And the x to the second power will be our output. This is related to in the machine.
This is an example of a known function, because the x1 is not determined with the yd in this example, so it's not accomplished the function. In this example, we can show you that in the x, all the numbers are different, like in the y. So here in the function, the x will be different than in the y, and the number is not repeated. Now in this function, we have f is equal to red apple, blue sky, and white cloud. So here is the domain A and the range B. So red apple, blue sky, and white cloud. It's like the examples A, B, and C, but here we have words and objects. So the first one is like the x1 and the y1. And here we have red apple.
So this is another easy example of a function. Here we had data in the x circle and in the y circle. So this data, we're gonna transform it in the one of the graph. Like 5, that is the x1, and 1, 7 and 3, 4 and 5, and 9 and 8. This one, it's a function, because we had the information of the x and the information of the y, and we have the correspondence for making this one. So here we find another example of a function. It say, if x, it's x to the third power negative 2x plus 1 divided by x plus 1. Find f equals negative 3. So, f negative 3 is equal to negative 3 to the third power, negative 2, negative 3, plus 1 according to our equation. Negative 3 plus 1. So here we're gonna solve it. Negative 27 plus 6 plus 1, negative 2. And this one is 10. So f negative 3 is equal to 10.
Now we're going to talk about the piecewise function. The function fx arranged three different functions. 3x plus 2 is equal, or you use it when x is less than 0. You use 4x when 0 is equal or less than x, or 5 is greater or equal to x. 2x2, you use it when x is less or equal to 5. Let's make some examples. If we have negative 3, we are going to use the first equation. We have 3 negative 3 plus 2 is equal to negative 7. In the second example, we have 0, so we use the second equation. 4, 0 is equal to 4 times 0, 0. In the last one, we have 2, so we use again the second equation. 4 times 2. Find the inverse function of a function. We have to follow 5 steps. The first one. First step. Change the variable x to y. So fx to y. For example, now this equation is written as x. Now we are going to change it as y. So y is equal to 19y plus 8 over 3. This is the first step. Now the second step is like this. Is to switch the variables again. So if we have this one, if you remember, we have to change it into y. Now again to x. For example, this is going to end like this. X is equal to 19 y plus 8 over 3. This is the second step. Here to multiply x is equal to 19 y plus 8. So 3x is equal to 19 y plus 8. This is equal to 3x minus 8 is equal to 19y. 3x minus 8 is equal to 19. This is the third step. The fourth step is to write the equation to prove it on the equations. So this equation, it's written as the inverse function of x is equal to 3x minus 8 over 19. The last step is to prove that the inverse function is correct. So we're going to take this equation, and in the variable we're going to switch the inverse function that we obtained. So we have 19. Instead of x, we are going to put the equation we obtained, which was 3x minus 8 over 19 plus 8 to complete this equation. This all over 3. Okay, now we're going to continue. Okay, now we have 19 and 19, we can cancel them, and we have 8 and 8, we cancel them. This is equal to 3x over 3. This is equal to x. If you obtain x, the answer is correct.
For news, we're going to create a debate about the trigonometric use and all the function use in the daily life.
Well, we can say that the functions are very useful in our daily life because, for example, when we go to the market, we can find a lot of products and a lot of different prices. So we can relate this to a domain that would be a product and a range that would be the different prices of that product of all those many products.
As well, we know that the application of trigonometry could be telecommunication, construction, and distances. We could know that trigonometry is applied on telecommunications because we could know the distance in which the sound and the radio extends between the space.
Also, we can use them in the playing billiard because by using the trigonometric functions, you can take into account them and use them to play in a way that you make a play in which you try to win the game.
As we can see, the trigonometry involves the history. For example, the Egyptians, they used the trigonometry to create the pyramids.
Also, you can find the trigonometric functions in physics for answering some problems, like taking out the height of a tree by using its shadow.
Also, we can identify the trigonometric functions in the hospitals, in the machines of the cardiac rhythmic. We can also identify when a person is dying because the trigonometric functions are involved.
We also know that trigonometric functions are involved in constructions. For example, when engineers are constructing bridges, they gotta know a lot of trigonometric properties to do it well. So maybe we can make more applications to trigonometric functions